Okay, today we're going to solve trigonometric functions. Here's the first problem that we're going to do. Tan of x plus cotangent of x. Over on the right, you can see the identities that we're going to use in order to solve this problem. First off, tan of x equals sine of x divided by cosine of x. So we're going to replace that over here. Plus, then, cotangent of x is cosine of x divided by sine of x. Notice that these functions are opposite. So we have cosine of x over sine of x. Okay, so in order to solve this problem, we need to find a common denominator. To do so, we have to find the common denominator, which in this case is cosine of x times sine of x. So we multiply sine of x times sine of x, giving us sine squared x plus cos of x times cos of x, which is cos squared x. As you can see over to the right, sine squared x plus cos squared x equals 1. So over here it writes 1 over cosine of x times sine of x, which can also be written as 1 over cos of x times 1 over sine of x. So, in conclusion, since 1 over cos x is secant of x, and 1 over sine of x is cosecant of x, this is our final result. So, this is the second problem that we're going to solve today. The identity that we need to know is that tan of x equals sine x over cosine of x. So first off, notice the following. Cos squared x minus sine squared x is a difference of squares. So what we can first do is write down the difference of squares, which is cos of x minus sine of x times cos of x plus sine of x. So then we divide it by, notice that cosine of x is factorable, so we factor out cos of x, then we write cos of x plus sine of x. These two are divisible by each other, so they cancel out, leaving us with cos of x minus sine of x over cosine of x. Then we have cos of x over cos of x minus sine of x over cos of x. This is equal to 1 minus sine of x divided by cos of x is sine of x. So giving us with tan of x. So this is our final result. So this is our third trigonometric function we're going to be solving, and we're going to be proving that tan squared of x times sine squared of x equals tan squared of x minus sine squared of x. These are the trigonometric identities we're going to be using, and they are tan squared of x equals sine squared of x over cos squared of x, and sine squared of x equals 1 minus cos squared of x. Tan squared of x can also be written as sine squared of x over cos squared of x. So we're going to write sine squared of x over cos squared of x times sine squared of x over 1 equals tan squared of x can also be written as sine squared of x over cos squared of x minus sine squared of x over 1. In the left side, you can multiply across, so you're going to have sine to the 4th power of x over cos
squared of x. And in the right side, you're going to try to look for a common denominator. So you're actually going to multiply sine squared of x over 1 times cos squared of x over cos squared of x. That's going to give you a common denominator of cos squared of x. And in the numerator, you're going to have sine squared of x minus sine squared of x times cos squared of x. You can also rewrite this as sine to the 4th power of x over cos square of x equals. Notice how you can factor out a sine squared of x in the numerator, so that equals sine squared of x times 1 minus cos squared of x over cos squared of x. If you go back to your trigonometric identities, you'll notice that 1 minus cos squared of x is the same as sine squared of x. So 1 minus cos squared of x is the same as sine squared of x. So sine to the 4th power of x over cos squared of x equals sine squared of x times sine squared of x. That's sine to the 4th power of x over cos squared of x. And this is our final result.